Okay, so in this short video, we will be trying to explain about the data science pipeline. Okay, so this is a data science pipeline. We need to have a sequence of steps that you need to do if we want to do a data analysis kind of a thing. So this is quite different from what you do normally. Given a problem, you'll be writing an algorithm, and then you will be just coding it and program it, right? So in that case, you know precisely what is the input and what is the output, and you also know what are the steps involved, and those steps will be there in the algorithm itself, and then it will be executed. And so, for example, if you take the sorting of numbers, you know what is the input and what should be the output, and you know the steps involved from converting unsorted number list of numbers into sorted list of numbers, right? So the algorithm is very specific, and you know the method how to do it, right? But in the case of the data science pipeline, generally what we do is so generally there is some kind of a decision making that needs to be done at ultimately, right? And for the decision making to be done, you need to predict something, you need to forecast something, right? And if you want to predict something, so you need to have past historical data, and that historical data that has to be given as an input to the system, and the system has to write its own algorithm using the machine learning kind of techniques, right? So you are not going to write the steps of how to convert from the input to the output. The system is going to find it on its own. So that is called the model building, right? So here the main step which is involved is the collection of the data, and the collection of the data has to go as a training set for your modeling to be built upon, right? So for that to happen, you need to follow a sequence of steps. Okay. So in this case, here, if you see that, so there is a sequence of steps which is happening from here to here, right? So one is the data collection, which is called as the wrangle. Okay, so data will be there elsewhere in several kinds of formats, right? Several modalities also will be involved. It might be a speech data, it might be a image data, it might be a video data, it might be a text data, it might be a numerical data. All kinds of data might be there. You may have to collect all those things in one place and then have it, right? So that is the one first step that will be involved, and then you need to do a kind of a cleaning. So that's we have seen quite briefly in the starting of the class. We were looking just before the midterm. We were looking at the data cleaning methods which are available, and then the descriptive analysis, that is the data exploration methods, so that we have discussed in the even in the descriptive and the inferential also. So you have to deal with this various variables, and what is the range of those variables, plot them, and then find out is there any relation between the variables or the attributes, like that. So that is the kind of exploration you will be doing, and then you will be doing some pre-processing also regarding that. So data cleaning is differentiated between the from the pre-processing, in the sense that cleaning is just like you would be leaving some of the data, or you would be modifying some of the data there. But in the pre-processing steps, it is like you are looking at the way in which the data has to be present in such a way that you can go ahead with the analysis. Okay, so pre-processing is slightly different from cleaning. Okay, so cleaning is more like a noise removal, and pre-processing is more like, of course, you have removed the noise, but still there might be some kind of an outliers. Some exceptional cases might be there. So what are you going to do with those kinds of outliers? So that is what is you might be doing with the pre-processing steps. And once that is done, we will be looking at the modeling. Modeling part is like, if you are going for a binary classification, what kind of classification you would be training. You will be getting the training data, and right? So, or if you are going for a multi-label classification, what kind of algorithm that you are going to look at, or whether you are going for a supervised kind of a learning, or you are going for an unsupervised kind of a learning. If it is unsupervised learning, what kind of clustering algorithms that you will be doing, right? So that is a training step that you will be looking at. So this is modeling and training, right? So the next step is, once you do that, you need to validate whether your training is sufficient or not, right? You need to check whether your data is your algorithm is working correctly or not. Once you do the validation, just by checking the accuracy and even the precision and the recall of these of the results that you're getting, right? And then once you are done with that, then you can build a story around it. So build a story means it is the inference that you make out of the prediction that you have already done, and that story will ultimately lead to some kind of an actionable items. It can be something like a decision making kind of a thing. Okay, so that is what we will be looking at in the data science pipeline. So this is a sequence of steps that you need to go through one by one, and then you need to come to the solution. But although I'm saying that these are all steps which are involved, like it is mutually exclusive, it is not completely mutually exclusive. If you see that, so there are some steps which you would have to repeat it again and again. Sometimes you might be exploring the data, and then you go to pre-processing, and then you model it, and then you see that the modeling is not perfect. So you may have to again do some kind of an exploration, and then you need to do some kind of a pre-processing, and then again you do modeling. So that kind of steps you may have to do it again. So these steps can be something like, even after you model it, and you might find out that data is not enough. So you may have to collect some more data. So you may have to come back to the data set collection again, and then you may have to go back to the step and then redo the step again. So although the steps are kind of sequential, it doesn't mean that you would not come back to the first step if you feel that it is not good. Okay, so that is the thing that you need to keep it in your mind. Okay, so now let's see. In some other places, the data science pipeline is also called as a data science flow. Okay, so it's also called as OSEMN. Okay, OSEMN. Okay, so O is meant for obtaining the data. S is meant for scrubbing the data, or just like the cleaning the data, and E is meant for explore or visualize the data. Okay, so that is more of the descriptive kind of analysis that you are doing, and then you model the data, that is called the training, and then you interpret the output. Okay, so that is also called as OSEMN. Okay, so now coming back to the case studies that we are looking at. So when we are looking at the data science pipeline, there might be two kinds of occasions that you can look into. One is you are already having a data set, right? So for example, the COVID data set is already there. If you go to covid19india.org, the COVID data set with respect to India is already there. Now, what is your question that you need to ask on top of that, right? And what are the patterns that you need to look at? So, what kind of prediction that you want to look at? So, how many people will be infected? When is the peak that is going to come? So, these are some of the questions that you can ask when you are looking at the COVID data set, right? So, you need to first precisely frame your questions, very specific questions, and then you need to go for, if you want to address this question, what kind of analysis that you need to do, right? So that is very important. So that is one scenario. The other scenario is you start asking a question, and then you try to get the relevant data according to that. Okay, so both the things can occur. One is the data set is already there, you do the analysis. So that might be the case in most of the occasions when you are looking at some of the data science company. If you are going for a job in a data science company, you would be getting a data set from some of your clients, and then you need to do some analysis, and then you need to answer some questions that you are giving it to them. So the data set is already available to you. You may have to do the data cleaning, data pre-processing, such kind of steps, right? But the data is already there with you. The data collection may not be a very big job if you are doing the this kind of a thing. But there might be other questions. So if you are doing a kind of a research, right? So you might be asking some research questions in which, like, you have to collect the relevant data. How are you going to collect the relevant data? That has to be defined by you, because the data will be elsewhere in many forms and many kinds of modalities also will be there. So, right? So you have to find out how are you going to collect the data and how are you going to collate it into one kind of a table, so that you can look into that table and then do some kind of an analysis, right? So both the questions are there, both the scenarios are there. So you have to keep these two things in your mind. Okay. So let us see one or two examples regarding the COVID data set which I was talking about. So the COVID data set is already there. You can have a look at covid19india.org. It's a very nice way of collecting the data and making it available to the public, so that whoever wants to look at the data, they can do some kind of analysis if they want to answer some questions, and then they can publish it somewhere else, right? So here, this case is the data set is already available to you. And now, so for example, if I want to look at the dynamics of the positivity rate, so how does the positivity rate varies from maybe the starting of the COVID, right? Maybe around the mid of March and until now, the end of November. How the positivity rate has changed, the dynamics of it, right, in India. Or you can also look into some states, maybe in Rajasthan or maybe in Delhi. What is the dynamics of it? So suppose you want to look at the positivity rate. So what are the data relevant to that? So if I want to look at the positivity rate, there are two kinds of attributes that you may have to look into. One is the number of tests conducted. So let me change the ink. So number of tests conducted every day, right? So number of tests conducted every day. And you may have to look into number of infected people, right? So number of infected people. So these are the two things you need to do, and the date also, because it is a time series data. So every date, I need to know the number of tests conducted on that day and the number of infected on that day, right? So suppose I say this is I and this is T, then I can find it like I divided by T, right? So I can find the ratio of this, and then find the positivity rate. So the positivity rate is I divided by T. And then now you can straightforwardly plot this, and then you may do some kind of a prediction. What will be the positivity rate in December or in January? Whether it will go to zero, or maybe WHO also tells that the positivity rate has to come less than 5. Then only you will be in a safer kind of an environment, right? So when it will be coming less than 5, right? So that kind of a prediction that you can do. So that is one of the problem that you can look at, right? The other one is you can do a SIR kind of a model. SIR model it is a separate kind of a model which is there in the epidemiological study and in the information diffusion area, in which we would be looking at how the viruses propagates in the population, right? Or the information is diffusing in the population, right? So this is well studied in social network analysis, which I'm planning to offer in the next semester. So interested people can take that, right? So this SIR model, it talks about the three kinds of sets actually. So S is for susceptible. Okay, so susceptible. I don't know the correct spelling, so just excuse me for that. So susceptible, infected, and recovered. Okay, so these are the three sets we are looking at. So susceptible is the population which is not affected as of now, but they are susceptible to be affected, right? So infected is the number of people who are infected on that day, and recovered is how many people who have recovered from it, right? So this is the SAR model, and now you have some set of equations which are related to SAR model. You can model that. If you can take the data for every day, how many people are susceptible, how many people are infected, how many people are recovered, then you can model it through the SAR model, and then find when the peak will come, when the number of infected people will come down, and the so such kind of analysis we can do using the simple SAR kind of a model. And for that, you need to have the data set related to the number of susceptible, number of infected, number of recovered for every day, right? So once you have that, you can feed that into the system, and you have a differential equation for SIR, and the differential equation will learn that from the data that you are giving, and then it will try to predict it for the next few weeks or few months or so, right? So the SAR model will not be that precise. You may have to go for more advanced kind of a model. SAR is a very, very simplistic kind of a model. Okay, so but I'm just taking it as an example. Okay, so for you. And there are other problems in which we were looking at was the exogenous infections in the case of the COVID. So what do you mean by exogenous infection is so suppose you take a state of Rajasthan. There are some set of people who are infected within Rajasthan, and there are some set of people who are coming outside from outside Rajasthan and coming to Rajasthan, right? So they are infected already and they are coming into the population now, to the Rajasthan population. So they are called as exogenous sources. And how much of exogenous sources is impacting the number of infected people in the state of Rajasthan? That is called as a exogenous infections. Okay. So how will you find out can you find the prediction, like how much of exogenous impact was there in the number of infected people in Jaipur and in other places in Rajasthan? So such kind of things may not only you may not be able to rely only on COVID-19india.org. You may have to get some data from outside, because so here we are talking about exogenous sources, right? So I'm talking about people who are moving from Delhi to Rajasthan, or moving from maybe eastern part of India to Rajasthan, or Kolkata to Rajasthan, or South India to Rajasthan, right? So those people, how many are moving into the state? So that you need to find it out. Somehow you need to have a kind of a rough estimate of how many people are getting into Rajasthan, and then you may have to get the ratio of how many people will be infected. So you take a rough estimate of the infection from those states from which people are coming, and then you need to find the impact of the exogenous sources. So in this case, it is not only the data that you are already having from the COVID-19india.org, but you need to collect some data outside that COVID-19india.org. And then you need to collate everything in one place, and then you need to do the analysis. Okay. So in these cases, so if you see that, so data collection is the one which I'm talking about right now. The data collection may not be from one place. It can be from multiple sources actually. So if it is from multiple sources, how are you going to collect all those things in one place? And then, because some data might be in image format, some data might be in video format, some data might be in text format, but how will you convert that into one source, and then you can do the analysis, right? So that is going to be a not a very trivial task, right? So these are the things that you need to keep it in your mind when we are looking at this data analysis. And the other point is so once you have collected the data, so sometimes what you may have to do is you may have to do some data augmentation also. So because the data you have collected may not be sufficient enough, So you may have to do an augmentation on top of whatever that you are having. Okay. So in that case, so that step is called as a data augmentation. Okay, so you may have to do this also when you feel that the data is not sufficient enough. You need to collect some more data. Okay, so if you see that in this data science pipeline itself, this part, which is the data collection, data cleaning, data exploration, and the pre-processing, right? So all these steps, so generally some people say that it constitutes 80 percentage of your time. Okay, so 80 percentage of your time is spent on collection of the data, cleaning of the data, exploration of the data, doing some pre-processing. Only 20 percentage is required for modeling, validating, and telling the story. Because for 20 percentage, you already have these algorithms as packages. You have to just you have to use the whatever the algorithms are there for classification algorithms, supervised or unsupervised, whatever it may be, right? So, or you are going for deep learning kind of a method, whatever it can be, right? So, those steps will require only 20 percentage of your time. So the laborious process is about the collection, cleaning, exploration, and pre-processing. Okay, so you need to do this step, although it is a very laborious, very hard kind of a work. Where we need to do this correctly, then only this 20 percentage will be a good, efficient kind of a prediction that you can do. Okay, so it's a very very important step. The second case that I can look into is one of the topic that we were looking at just a few months back. So we were looking at what kind of tracking is being done in the Indian news website. So this is a question that we are asking. So this is a research question. Okay. So now you are talking about a research question. So if you want to answer this question, now I need to collect the relevant data. So what is the relevant data if I'm looking at this kind of a question? So what are the relevant data? So there can be many ways of doing it, but this is one way of doing it. Like so suppose I want to find in the Indian news media website, how many Indian news media websites are there. So somewhere I need to get that kind of a collection, right? So there may be some hundreds of Indian news media website will be there. Like it might be in English language, it might be in Hindi language, it might be in other vernacular languages. So now if I want to get all of them, it may not be possible at all, right? So let me first try to look at the 100 maybe very popular kind of news Indian news websites, which are covering almost like 90 percentage or 80 percentage of the people, right? So if you want to going to look at that kind of a thing, so then I have to go with some kind of a ranking. So is there a kind of a media rank which is there in India? So that you have to look into. Okay, so you can look into some of the websites. There is a website called Alexa. Alexa, that is from Amazon actually. So Alexa, it ranks the websites according to the number of visits to its website. Okay, so in that we can look into the Indian news websites. So you look at the category under in the Indian news websites, and then you collect all the popular websites which are there. But so when we looked at we could cover only 40 percentage of the Indian news media only, right? So even some of the popular news websites are not coming in the Alexa ranking. Okay, so now I need to do a data augmentation. So this data is not enough. How I'm going to do the data augmentation? So the data augmentation I will be doing some using some kind of a method, systematic method. So one of the steps that you can look into is there any kind of a ranking which is already there in within India? So there are various websites with respect to the Indian media, even the government websites are there, which ranks the readership according to the readership. It ranks the websites. Okay, so you can look into those websites. and then you can get some data which we were looking at. So we were able to cover the rest of 60 percentage of the Indian news websites. So like you can roughly say that 100 websites we wanted, and 40 we got it from Alexa, and then the other one we got it from the Indian ranking websites. Okay, so this is Indian ranking websites. Okay, so once we do that, then now we have the news media, right? So so all the news media websites have been collected now. So this is one process only. Now, if I'm going to look at the tracking in the Indian news media website, now I need to look at the content of these websites also, right? So now I need to look at the content. So how am I going to look at the content? If I'm going to look at the content, am I going to look at the first page of their main websites, or I'm also going into look at the other pages, right? So there may be many pages within timesofindia.com, right? So if you go to timesofindia.com, there is a one main web page that is coming, but there are multiple pages from there. You will get the links. You may go to metropolitan city news, or you may go to some state news, you may go to Rajasthan news, you may go to international news, you may go to sports news, you may go to entertainment news. All those things are there. So how I'm going to look at the tracking, which is done in separate pages, right? So if I want to look at the other pages also, then I need to collect all the data, the content of the data, right? So if I want to look at the content of the data, then I need to crawl those websites. So if I want to do the crawling, then I need to write a script that can be automated, so that it will do the it will collect the content using a script, using an automated script. So, and that's what we did using a simple Python crawling script. It was able to collect all the data, relevant data that we are looking at, and then once we get the content, then we can look into the tracking. So how many cookies were there? How many? What are the types of cookies are there? So then, so if you are looking at the cookies, then you need to look at the domain specific. So you need to look at some of the people who are working in the security aspects or in the privacy aspects. So the security and privacy aspects people, they will be looking at the different types of cookies. So you have to get the knowledge of different types of cookies are there, how it is represented in the web pages, right? So if I want to look at the so for example, if I want to look at some specific cookies which are doing the fingerprinting kind of tracking, then what are the specific things that I need to collect from the content of the data, right? So such kind of things you have to do it, and then we need to do the analysis part. Okay, so these are the some of the things that you may have to do within this 80 percentage of the thing. So once you do that, then you can do a kind of an exploration. So the exploration is about studying about the different kinds of variables. What is the range? What is a relation between the other attributes? Whether there is some kind of a correlation between any two or three attributes, right? And then you need to look at what kind of model that you need to build upon. So if I need to classify whether this kind of a tracking is a good tracking or it is a bad tracking, then I need to look into the aspects of what do you mean by a good tracking, what do you mean by a bad tracking. So if I'm looking at good tracking, so then it might be looking at only your maybe your preferences, and according to your preferences the next pages will be loaded, right? So in the case of a good kind of a tracking. But if it is a bad tracking, what it will do is it will give you some kind of private information about you to maybe some third party people, right? So that kind of a things that can occur. So now using this kind of a analysis, you may have to predict whether this kind of tracking is good or this kind of tracking is bad, right? So if I want to do that, then I need to find the definite features which will define what is good tracking and what is bad tracking, and then I need to train the model. So this is going to be a now binary classification kind of a thing. So I may look into whatever the classification algorithm we have seen, whether it is SVM or whether it is a naive-based kind of an approach, whether it is a decision tree kind of an approach, whether it is a rule-based kind of an approach, and then you need to train that, train the whatever the data that you already have, and then you can validate it with respect to some maybe human labeled kind of a data, which you can treat it as a kind of a baseline for you. And I mean, not the baseline; it is a ground truth kind of a thing. So you can compare it with the ground truth, and then say how much accuracy you have, and how much what is the amount of false positive that you are having, and that will give you some kind of an indication about how much algorithm how good is your algorithm, right? Once you do that kind of a thing, then you can say that there is a significant amount of tracking which is happening in the Indian news websites, and now you tell the to the tell to the world that this is what is happening. You are being tracked by these kind of websites in this kind of manner with this kind of cookies. Now you are losing out your privacies. Now you take your decision. So this is just like informing the public, like, so this is what is happening. Now you think about whether you want to so you want to continue with this, or whether the government is government has to make some kind of a decision, because India still doesn't have any kind of a privacy policy, it's exclusive privacy policy. So now the European Union has come up with a privacy policy. Even the US doesn't have a privacy policy. Some of the federal governments, like California, has a privacy policy, but not all the states are having privacy policies in the US. In India, the privacy policy is nowhere actually, right? So you can do with whatever that you want in the website. And what we have found out is like the amount of tracking which is happening in the Indian news website is very huge, and it's a very kind of very what to say, it's a very very sensitive manner, but the people or the government has not looked into this kind of problems that we are already having. Okay, so and the medias are taking this kind of an advantage, and they are doing whatever nonsense that they can do in the websites, right? So so this is the thing that I wanted to tell you, like so taking these two case studies, I wanted to give you a picture about the what are the steps that is involved if you are going through the steps, like the data collection, the data cleaning, the data exploration, and the data pre-processing, the modeling, and the validation, and then making inferences, and then doing creating some kind of an actionable points to do the decision making. Okay, so I hope you are able to understand this point. So if you have any clarifications, or if you have any doubt regarding this video, you can ask either in Piazza. So Piazza is it's for the CCE students. They can ask in Piazza, or if you are comfortable, you can I can open the thread in the Moodle also, so that the CSE students also can ask questions if you have any doubt. Okay, so so let me stop this, and so all the best for your exams, and hopefully we will meet again in the next semester.